Today we're going to talk about brew by weight DIY for the Linea Micra using the Acaia Lunar scale. So a couple months ago, Marzocco came out with a brew by weight functionality for the Linea Mini using the Acaia Lunar scale, but they created a little bit of a community uproar in the enthusiast espresso community because they did it by taking the Lunar and adding their own custom firmware and selling it as a separate product. So if you already had the scale, you're out of luck. You have to buy La Marzocco's scale for $400 if you wanted to have the brew by weight functionality. And there may be some technical reasons as to why they did this. There's a lot of speculation online. I won't go into that, but really what it got me thinking about was, is it feasible to do it on your own externally? And a lot of people, they just want to buy a finished product, so I don't fault them for that. But I wanted to see what it would take, and so what we have here is basically the finished product, or at least as finished as I'm willing to go with it. Got a little controller here that I put together. If I hit connect here, it connects to the scale. It has a weight, it has a brew rate in grams per second, and then a target. So when it hits the target, it should shut off, and then a little timer that resets when you start. And it's got magnets in the back, and so I can just kind of stow it away here. I could make it totally wireless, but I just don't want to go to the effort. So throughout the rest of this video, I document kind of the steps I took to develop this, but I'm just going to skip to the action here. So I've got a target set here of 42. There's a little joystick you can adjust up and down, and then going left and right does tenths. And then you press it to lock it in, and that's why it's bold. The target's bold when it's actually enabled. Otherwise, it's just kind of manual control. So let's also talk a little bit about what this actually is. So this is a Raspberry Pi Zero, and it's controlling a relay inside of the machine. And then it's also got Bluetooth, so it connects directly to the Acaia scale, and it's able to read the weight. So if I push on the scale, you can see that the weight comes back here, and we get the flow rate and everything. So it's Bluetooth connected to the Acaia, and then I'm just controlling the relay inside the Micra. So the reason why I chose the Raspberry Pi Zero is because there were already Python libraries to control an Acaia scale, so it just kind of simplified things for me. I spent a little bit of time trying to get just a microcontroller talking to the scale, but I decided it was going to be too much work. So let's go ahead and jump into it and demonstrate. The rest of this video afterwards is about the process and how I actually developed it. But just to kind of jump into it and demonstrate, let's do that now. So we're connected already. So all I have to do is press this button, which controls the paddle. And again, if you have a target set, it will auto shut the paddle off, or auto shut off the paddle. I don't know how to say it. Let's go ahead and kick the paddle on. And the timer starts when I push the button, rather than at first drop. This is the first shot. There's some learning in here where it will keep track of the overshoot and try to get closer to the target over time. So that's not too bad, a tenth off. If I let it drip a little bit, it may go over. But in a nutshell, I mean, that's basically the functionality that you get. Pretty straightforward. So that's not too bad of a shot, all things considered. So yeah, this is La Marzocco, why can't I say that? La Marzocco Linea Micra and the Acaia scale, and then using Bluetooth to read the scale, even control the scale, and then use a relay to use the paddle here. So the paddle still works. I'll just move my scale here. So the paddle still works. There's just a relay in parallel, so it's kind of like an alternative switch or an extra switch inside the machine that can also control the paddle. So if I wanted to control the paddle manually, I can do that just by pressing this and shut it on and off. So when I'm done, I just stick it like that with the magnet and we're all good. So here I'm showing the internals of the Micra. When you open the top lid, you'll see the top of the brew chamber here, and I've highlighted some connectors that you need to remove in order to reach the wiring bundle for the paddle. When you pull up this wiring bundle, you will find a black and a white cable. The thick ones go to the paddle and the thin wires go to the controller inside the machine. This is really just a switch, so when we connect these two smaller cables, it actually flips the switch on. So the circuit here is pretty simple. We've got a relay on the left in parallel with the Micra paddle switch, and then we have a 5-volt power source that's connected to both the relay and the Raspberry Pi Zero. And then finally we have a GPIO 23 pin which controls the relay. Okay, this is my first test run. You can see I've got the relay connected in parallel here. I've got the power, 5-volt power running there. If I press this key, it should turn on. Okay, this is my first attempt at brew by weight. I've got my relay plugged in to replace the paddle in parallel here. I've got my little controller here. The first two buttons connect. The last button starts. And then the joystick I can use to adjust my target. So I can go up and down, and left and right does tenths. So I'm going to target 42 and I press the joystick to lock it in like that. You see the bold there. Now I expect it to overshoot a little bit just because my programming to stop at the target is pretty simplistic. But let's give it a shot. Trial number 1. The shot timer actually starts when I press the button, which is nice. Okay, so 2.5 grams over. Looks like I need to fix the timer because it restarted. But that's not too bad for a first run. Just need to adjust the anticipation, I guess you could say. Okay, this is experiment number 2. And what is different from number 1? Well, I've added some learning here. It will learn from the previous shot as far as the overshoot. So if it goes over my target, it will eventually learn and try to get me as close as possible to my target. So let's give this a shot, no pun intended. Let's go down to 42. We'll lock that in. And I'm gonna press key 3 to start the shot. Got some pre-infusion. I don't care about getting a perfect shot here, just so much as testing the target functionality. So you can tell that it's a slow shot. Okay, so we're about 0.4 short this time, 41.6. So I'll reset it, I'll prep another shot, we'll give it another try and see if it learned anything. Okay, I'm all reset, brand new shot. This is experiment number 2, part 2, I guess you could say. I'm just gonna lock in my target again at 42. And then we'll start the shot. We'll see if we get any closer this time. Just 1/10 off. Oh, 2/10. Still pretty good. So this will be the final update on my brew by weight project. I got all the wiring tucked away, run through the machine, and I found this nice silicone wire that is very flexible and heat resistant. Made a little 3D printed case for the controller, makes it easy to use, and it's got magnets, so when I'm not using it I can just stow it away here on the side or wherever I want. So let's go ahead and give it a try. Let me set the target. Works the same as it did before. So let's go for 42, and we'll start it by pressing the bottom button. I'm not a huge fan of how close the buttons are with this controller, but it works. We've got to get it off pretty quickly so it doesn't drip too much. I notice the dripping is the biggest variance. So I think overall it's a success. So I tried a few different algorithms to try to hit my target rate the most accurately, and I found I can get it within about 1/10 of a gram usually, unless I let it sit for a while and then it starts dripping extra drops of coffee from the puck. There's a little bit of a delay when you shut off the solenoid. The puck is still full of liquid, and there's more liquid that comes out, and so you end up kind of overshooting your target. And I tried a few different things to overcome this. One was taking the flow rate and adding it to the actual weight to try to estimate in advance, I guess you could say, when you should shut it off. So For example, if I was at 42 and my rate was 2 grams a second, I would maybe try to shut off a second earlier to try to anticipate when I was going to hit my target. I found that was really kind of unnecessary because the measurement, the Bluetooth measurement in real time is so fast. The latency is like tens of milliseconds. So fast that I can just actually shut off when I hit it. I don't have to try to guess in advance. The bigger issue is estimating how much liquid's going to come off of it once you shut off the solenoid. So you can shut off the solenoid accurately just by reading the scale and then shutting it off in real time. But there's always some extra that comes out, and that's going to depend on how finely you've ground the coffee, how warm the water is, and other factors. So what I've found, what I settled on is the easiest way is to just remember how far over you were last time and use that and shut off early. So you take the current weight, you add the overage from last time, and then when you hit your target, based on those numbers added together, that's when you shut off. And it's really super accurate. You don't have to have any machine learning or have data on thousands of shots to get within a tenth of a gram. And I like the results.